All right, this is example 15.3 on page 502. As a chemist does the following reaction, she knows that the equilibrium constant for this reaction is 0.050. She already knows that. Suppose she knows the concentrations of each of the substances are as follows. Your N2 gas is 0.15 molar, your O2 gas is 1.3 molar, and your NO is 0.020 molar. Determine whether the reaction has reached equilibrium yet. If it has not, determine the direction it will shift. Okay, so all you need to do is set up your reaction, your chemical equilibrium constant, just as we had before, with your products over to this exponent, over everything's a gas, so you have to put everything in, times O2, all right, and then put in the numbers. She knows her numbers already, so N2 was 1.5 molar, O2 is 1.3 molar, and NO is 0.020 molar. Put that in your calculator, the squared divided by, make sure you use your parentheses, 1.5 times 1.3. You have m squared on top, so your m's all cancel out. If you do not get this answer, it's not at equilibrium. So you put that all into your calculator and you're going to get a K of 0.00021. Okay, so remember what I said? If you get a K that's really big, that means you've made most of your products. If you get a K that's really small, you have most of your reactants still. So this is what our K is supposed to be, and this is what it actually is. So is this too big or too small? It's probably too small. It is too small. So that means we still have too much of this. This is if it's small. This is if it's too big. So if it's too small, that means I still have too many reactants. I haven't made enough products yet. So my reaction needs to shift this direction to get to equilibrium. So it's that you would have to say, no, this reaction is not at equilibrium, and it has to shift more towards the products. So you have to say two things in the answer. It's not at equilibrium, it needs to shift towards the products. Okay? The same chemist does the chemical reaction under different concentrations. Now this time she's going to get, I'm reading the second part of this. This is still squared. Now she gets her N2 to be 0.1 molar. She gets her O2 to be 0.2 molar. And she gets her NO to be 1.00 molar. I need to have another significant digit there. All right, so now it says, is the reaction at equilibrium under these conditions? So you have the same one. We're still going to figure it out, compare it to this number, and this time we're going to get a K of 50. Whoa, that's really big. So if it's too big, that means I have too many products and not enough reactants. So is this at equilibrium? Not the same number, so nope, not at equilibrium. And which way does it have to shift? This time it has to shift this direction. It needs to get smaller. It needs to shift towards the reactants. So two answers to these problems. Make sure you give them both to me. So you say, no, it's not at equilibrium, and tell me which way it has to shift.